Thank you for joining us today on this webinar. Yaron and I are super excited to have you here. Yaron will turn his camera on in a moment so you can see his face. But we are kicking off this series of webinars, which we've called, Can Your AI Platform Do This? And we'll kick off with little intros about ourselves. But the reason why we wanted to do this was because we wanted to kind of talk about the world of agentic applications. All those things is moving at a very fast pace, and have our perspectives around this. But before we dive into that a little bit more, let's just talk about a bit of our background and who we are. So my name's Mark. I'm the CEO and co-founder of Diagrid. I spent 20 plus years working at Microsoft and built many developer technologies there, including a platform called Service Fabric that ran many of the large Azure services. Then 8 years ago, Yaron and I started an open source project called Distributed Application Runtime, called Dapr, which was all about building patterns and APIs for building distributed applications that you can run on many of these emerging cloud native platforms like Kubernetes, and at the time there were others, but of course increasingly it's Kubernetes now. And that became a very successful project and got donated into the Cloud Native Computing Foundation. And then started Diagrid as a company where we focus very much on building distributed applications, open source, and making enterprises in particular take their journey into the cloud native world, and also now increasingly into the agentic world. So Yaron.
Everything Mark just said, only I'm the CTO and co-founder of Diagrid and also a co-creator of Dapr. If you're new to Dapr, then we will cover what it does in the context of LangGraph today. But yeah, extremely happy to be here and be talking to you. This is going to be a very interesting webinar. It's just the first out of many that are really going to cover all of the important aspects of running AI in production. But more importantly, maybe we can rename the series to Taking the Non-Happy Path, because pretty much every technology out there always shows you what happens when the happy path transpires, but the happy path, as you know, probably is never the real world production path. Everything goes wrong everywhere. And one of the most important things you can do is guarantee that when shit hits the fan, that you're ready for it. And this is essentially what we're about.
Yeah, we're all about shit hits the fan. That's what we want. And in fact, the bigger your problems that you have, we want to hear about them all. So this really is like unload your problems onto our space. We want to hear about them. And in that regards, what is it we do it at Diagrid? Well, we think about all about security and reliability of agents, and particularly how you take those into production. We've been working with numerous companies today, building agents, taking them into production, and really that transition where if last year, 2025, was all about the experimentation of building agents with different frameworks, and frameworks are easy to create. You can create an agentic framework in a week and play around with it all and things like that. That's not the hard problem to solve. The hard problem is, how do you take those experimental agents and take them into production, particularly focusing on reliability, security, and all of the other governance side around all this. So we've put together this sort of word chart of things that we've heard in the past about challenges for what does it mean to take agents into production. What are the things that you're seeing and what you're hearing? And what I'd love to you to think about is, as you look at some of these words inside here, please post in the chat channel inside here things that you would like to talk about, things that you've encountered. Either we can answer them as we go along, and we love that format. If there's a particular question you have around how you've seen a particular framework, these challenges you've had with that in terms of using it in a reliable, secure way, governance around this. There's a lot of discussion today about agentic governance. How is it you manage, deploy, understand where these agents are running, the explainability of what they do, understanding how they behave, how they have access controls around these things. That's a whole topic in itself. There's a whole topic around MCP as a security as a protocol, security around it all, how you manage MCP servers, how you manage access to them. That in itself is something we can dive into. Please, let's at the end post some of those questions and hear some of your thoughts. We're really here to think about what are your challenges and what are the things that you care about from a production perspective for agents. The more, the merrier. So I guess with that, let's kind of dive into thinking about some of what are some of the agentic frameworks today. So your own, let's take us through some of this.
Yeah, of course, every agent framework you're seeing right here in this slide is an agent framework that is considering itself to be ready for production usage, but our take is that none of them, with the exception of Dapr agents, but even if you take Dapr agents out of the equation, none of them really is from the reliability perspective. Most of the frameworks today, they focus on evaluation, debugging, troubleshooting, just reasoning loops, LLM abstractions. But when it comes to really making sure that you've got things like security and reliability across the board, they're lacking in many aspects. And today, we're going to be picking on one very particular framework, which I think is the most widely used one today, which is LangGraph from LangChain. But what we're going to be covering for LangGraph, I can assure you, after deep diving into the architecture of every agent framework here, everything we're showing for LangGraph is applicable to pretty much any agent framework here, maybe with the small exception of Microsoft Agent Framework, which does actually a pretty decent job when it comes to reliability if you're in the Azure ecosystem, but even better with Dapr. So yeah, a lot of those frameworks just need a whole bunch of feature sets that they don't natively ship with because they're focusing on the black box elements of AI, but not on the distributed systems challenges that have existed for many, many, many years and are just now getting amplified by introducing non-determinism into workflows.
Let's jump to the next slide. So
today, we are going to take a special look at how LangGraph handles reliability, where it breaks, and I chose a background which is pretty much like a nature landscape background to calm me down because LangChain a little bit pisses me off. And that's an understatement, actually. Maybe I should remove the little bit. I'm going to share my screen. I'm going to show you exactly what they claim they do and how they contradict themselves inside of their own documentation. And then we're going to see how that translates into a workload that runs at scale. But the problems I'm going to be showing you are not going to be just if you're running at scale. They're going to be just as true if you're running a single agent versus running 100 agents, like we're going to do today on Kubernetes. It's going to be a pretty nice scale demo to prove the ability of the Dapr workflow engine to handle pretty much any workload you throw at it. But the problems really are, even if you're running a single agent versus you're running 1,000 agents or 10,000 agents. So yeah, let's go into that.
Well, in this world, what we're going to do with Dapr as part of this, like how does Dapr kind of calm the waters, as it were?
So if you're familiar with Dapr, great, thank you. If you're a user of Dapr, thank you from the bottom of our hearts for using the project. Dapr is a graduated CNCF project. It's been around since late 2018. If you don't know what Dapr is essentially the technology that's going to be running next to your agent, MCP server, or application, and make sure that it picks up where it left off in the case of failure. This is what Dapr does today. It'll also connect your different applications with different APIs like PubSub and service invocations. You could wholesale replace service meshes with it if you want to in a very lightweight Kubernetes native way. It'll give you abstractions over databases and over other sets of technologies. But really, the focus that the project has taken in the last year and a half is to provide this underlying reliability and security for platform teams who are taking mission-critical workloads like payment systems or healthcare systems or retail systems into production and want to run them at scale without needing to fear that something's going to break when the scale changes or when new requirements are being introduced. So today we're going to see how Dapr plays along with LangGraph by allowing you to keep everything you have. Literally, your code stays the same, and when it comes to your agents, your CI/CD pipeline stays the same, your hosting environment stays the same, but you're actually getting an augmented experience where Dapr provides 4 nines or 5 nines, even depending on your compute requirements, levels of uptime for your agents.
All right, so before we dive into the demo, we're about to do a demo. Your demo does what?
So my demo is going to show you exactly why LangGraph doesn't survive the real world. And I'm going to have a Kubernetes cluster running, and I'm going to be running 100 LangGraph agents. And I'm going to have this small bash script that essentially orchestrates chaos, and it's going to be one hell of a chaos because we're essentially not going to be doing anything nice or gradual. We're going to be crashing everything everywhere all at once. I think there's a movie named that. So we're going to be kicking off 100 agentic workflows for each one of those agents. So each agent is going to pick its own workflow. We're going to have 100 agents kicking off 100 workflows. And then at some point, any point, this is, it doesn't happen after 3 or 5 seconds. At any random point, before it reaches the third step of the workflow, which is final edit here, it's a summary agent. We're going to kill the world and crash everything. And then we're going to restart and see what happens. And then we're going to compare what actually happens and what LangGraph tells you, LangChain, tells you happens with LangGraph. And those two are very distinct things. So Harrison, if you're watching this, there's going to be a few pointers to take, I think.
All right, over to you then, Yaron. Look, when you share your screen and take it away, are you going to dive into that LangGraph text yet, or should we go straight to the demo, or I'll let you take that on? Yeah,
for sure. I'm going to share the documentation. Actually, I'm going to start with that.
Okay.
So let me know when you can see it.
Yes, we can. You zoom in a little bit. Yes, there we go.
Yep. Okay, I'll zoom in even more. If you go to LangChain docs and you're looking at durable execution, you go, okay, well, it looks like, LangGraph has the ability to give me everything I need when it comes to reliability. And, we're not going to go over that text. This just explains in layman terms what stateful replayability is. And then they go, if you're using LangGraph with a check pointer, you already have durable execution enabled. Oh boy, if only it were that simple. And then they say you can pause and resume workflows at any point, even after interruptions or failure. This is very disingenuous marketing. We're going to get that in a sec. And then they're going over the requirements. They're explaining what determinism and consistent replay is. All very good and true stuff. Like all the benefits of stateful replayability are extremely important. You must have that when you're going into production. So what I want to do is scroll down a little further and get into where all the dreams that they're selling here are essentially turning into nightmares. The most important thing that you need to take into account when you're writing a checkpoint-based system, which is what LangGraph and any other framework is doing, is making sure that once you're saving the data, which is the easy part, it's very easy to just input a function after every tool call or LLM call, get the JSON serialized and save it into the database. That's a really easy part. The problematic part is to automatically resume from failures, because 80% of the job of a workflow scheduler is to be able to identify when something went wrong, and then being able to understand, well, what went wrong, where did it go wrong, and to automatically resume it at that step and make the entire recovery step also durable. Because if you have a step that is recovering 100 agents, but that recovery system in itself fails, then how do you recover the recovery failure,
Yes.
And then it just becomes this kind of like inception-based process where you'll find it's extremely difficult to build. So LangChain tells us this: recovering from failures, automatically resume workflows for last successful check after an exception. Lie, very big lie. But you realize this is a lie pretty early on, because the only thing you need to do is read this very contradictory next sentence. This involves, so automatically resuming workflows involves executing the workflow with the same thread identifier. Okay, so they're basically saying, yes, the workflow will automatically resume after you manually resume it. And this is batshit crazy. And we're going to see that happening in the demo.
In fact, there's a whole world of perfect failure detection and failure detection itself that is a crucial part of a distributed systems problem.
Yep.
And it's a really hard distributed systems problem to do the failure detection around these things. And that's the key element of this. This is something that basically we focused on a lot inside the Dapr framework as a distributed systems runtime.
Every workflow engine, and it doesn't matter if it's Dapr or Temporal or Orchest Conductor or Cadence or whatever, all of those code-first workflow engines have tackled the really hard problem of being able to automatically detect and resume failures when they happen in a consistent way, in a way that isn't even exposing you to really bad scenarios, like where you'll be kicking the exact same workflow twice or 5 times, right? Because there's a lot of things you need to worry about, even if you have the system that detects failures, and you're somehow able to create durability for that system, to be able to, in batches, resume workflows. And then if you have multiple instances of that, then you need to somehow start doing coordination across multiple instances to guarantee that you're not kicking the exact same workflow twice, because then you're in a shitstorm, which is called duplicated side effects, paying for LLMs, not even twice, but like 10 times if you're if you have the simplest of bugs, or retry mechanisms that are eventually retrying the same thing in multiple instances. So sidestepping that is a huge problem. All of those workflow engines that you're seeing with like Google Workflows, or Azure Logic Apps, or the Azure Task Durable Service, or the recently announced AWS Durable Execution Service, all of those are taking those really big problems. However, none of them have integrations with the actual AI agent frameworks that you're seeing, as in first-class integrations. You cannot take any of those workflow engines I mentioned previously and connect them to provide the underlying reliability for Crew AI, LangGraph, and LangChain, the same way Dapr does.
In fact, that's a key distinction between what a framework provides you and what an AI agentic platform provides, yes? Like frameworks don't solve these hard distributed systems problems as a whole, one of them being failure detection. The framework is very easy, which is why you can write a framework, a great example of a framework in a week, but writing a failure detector that gets used inside of that and then underlying workflow engine is a multi-year effort around these things. So
let's just do
let's dive into the demo. Let's look at that. Let's get
before
to
the demo. Before demo, just one small thought experiment about what it would take to actually write this yourself. So LangChain, every time you kick off a workflow, they return a thread identifier. Now, to be able to resume it in a failure, after a failure, you need to save that thing yourself. Now, ask yourself the following question. What happens if your process crashes while your workflow is now midway and skip, step 1 or 2 or 500, but it crashes before you're actually able to save the thread identifier into a database? Now, let's assume you miraculously were able to guarantee that every time you're able to save the thread ID before the first step of the workflow actually executes. Now, your process came back up and you're having multiple processes. Now, how do you know exactly which agent failed? How do you detect failures? So now you need to write a whole system to detect the failures. And after you've detected those failures and you've basically wrote them into a system of record, now you need to have some sort of reconciler running in the background that's going to take all of those jobs, while, by the way, agents are still running and new things might be failing while you're trying to recover the previous ones. And now you're going, oh, well, I have 100 agents that failed. How am I going to recover them? Now you need to start doing like a pipeline or batch work, and you're going to need to start recovering them one by one. But what happens if there's another issue and your recovery system fails midway? And it failed at agent 60 out of 100, or at workflow step 60 out of 100 for all of those workflows. How do you recover the recovery system? I'm sure you'll realize this is a very hard problem to solve. And let's just see how LangGraph deals with that today. So what we have here is a LangGraph application that is very simple. It's very similar to what you'd find pretty much on the internet. We have a state graph using a 3-node research, draft, and final edit. So we've got a 3-node workflow here, and this is the simple graph. And if we are going into the application here, we can see that in this demo, we have a PostgreSDB enabled. So we're using the check pointer, exactly like LangGraph told us we should. And we are connecting the check pointer to basically make sure that we have, I don't know if you can see me, durable execution in this LangGraph agent application. Okay, so I have a Kubernetes cluster and I have 2 namespaces. One namespace is running LangGraph without Dapr, and the other namespace is running LangGraph with Dapr. Let's just do a get deploy for the LangGraph one. So this is the namespace that I have here. And I'm not actually seeing anything, which is interesting. Yeah, okay. KubeCal just took a while, so I'm going to do this again. I've got this namespace here. We've got 100 replicas of 100 replicas for LangGraph. This is running without Dapr. And what we're going to do, as we saw earlier, we're going to kick off a workflow per each agent. And we're going to be taking a look at LangSmith, which is LangGraph's own utility, web online utility for watching those executions. And we're going to see exactly what happens after the chaos that is going to ensue, because, well, we're going to be doing it. So what I'm going to do right now is essentially kick it off and orchestrate that. And let me just go and do that. So I'm just going to kick off this workflow here. And what this is going to do is just connect to the different workflows. And this is going to do a curl and then just wait for them. So first of all, let's do a pod watch here. And we're watching this. And now if we go back into the Langsmith UI and going into here, we can see that there's a whole bunch of workflows that are being executed. And these are each individual workflows for each one of those individual 100 agents that are running on Kubernetes. And in a second, as you can see here, something not nice is happening. We're essentially killing everything all at once. This is an extreme failure mode. But LangGraph is not going to recover even if you just take a single agent and restart the pod and give it a graceful shutdown that can span for days. It will still not recover, and yeah, just stay there idle. But
are you doing the chaos on this? How are you doing the chaos on this? Are you just attacking each one?
In this case, yeah, I'm just issuing a command for the Kubernetes API server and telling it to restart all of the pods. This can happen due to so many reasons. It can happen because of a scale-out event, symbol bug in your code, when you're updating a version of your application, right? Like it doesn't even have to be a failure. It can be due to a planned rollout that you wanted to execute. So now all of those agents are re-executing. We can see that they are up and running, which is great. And we're going to see here, and lo and behold, we had checkpointing enabled, but all of them are red. All of them are failed. And at that point in time, we have orphaned executions, meaning even if you do spend millions of dollars and a bunch of 20 engineers to come up with your own failure recovery mechanism that detects failures and then invokes each agent exactly where it failed, and you're making that system durable, you will have still a disconnected view and a disjointed view of everything you're seeing. So all of that failed. Now, in comparison, let's see what's happening with Dapr. So hopefully I did not crash my actual Kubernetes cluster. That sometimes happened with GK. We don't have the biggest node here. Let me do just a get deploy for the Dapr system namespace. So we've got exactly the same agents running there, only with Dapr. So if we're looking at the pods that are running there, we can see that they have two instances because we have the LangGraph Python app, which you've seen earlier, but we also have the Dapr sidecar running next to it. And I'm going to show you what the actual changes in the application. Spoiler alert, it's extremely minimal. But before I do that, I'm just going to issue the orchestrating code again. So let me just kick this off this time with Dapr. And we're targeting 100 IPs, 100 ready. Yes, and now what it's doing is it's validating that we have 100 that actually started. And we're going to go here and take a look at those pods. In a moment or two, they are going to be executing again. We're waiting for a few of the research completion activities to start coming in. And as you can see, it updates automatically for us. So that's great. And I believe now it's starting to kill all of them. Yes. So we can go back here and the exact same failure scenario. They are all dying. And in a second, they are going to start coming back up again. Now, one of the great things about the Dapr workflow engine is that it's not going to wait until all of those 100 agents are going to come back up before it's starting to issue the workflows. So the most amazing thing about the Dapr integration here is that Dapr's workflow engine will start picking work as even the first instance comes into play. And as more of your instances come back online, it's just going to automatically distribute the work across Kubernetes pods that are running the Dapr workflow engine. And so you're getting a very low latency when it comes to actually picking up on the field work. But that remains to be seen because I haven't even proven that our workflows are continuing yet.
So can I just jump in here with a question? Because we got to ask a question at the same time of this. And they said 100 agents seem fine, but what if it was 10,000 agents running inside here? Or 100,000 agents? Okay,
same story. Now, if there is a big organization here in the call and they want to give us the compute to be able to run 100,000 agents on their compute, we are more than happy to do so. Seriously speaking, we will come and we will fire off 100,000 agents to show you even 1 million agents running and how Dapr workflow is actually able to recover.
Yeah.
So yes, the scale does not matter.
And effectively, the efficiency of this is pretty efficient because of the way we've built the workflow engine that distributes the work across the workflows across the Kubernetes cluster. So there isn't any one single cluster that has the piece of work, but the work itself is distributed for the workflow itself, which makes it very compute efficient and very scalable. Yes?
Correct. And while I was talking, we can see that with these latest runs, all of the workflows has completed. And I didn't switch back to the screen, but they never turned red. These workflows never turned red. Even during the failure, they stayed on as like this circling blue lines. But you know what you can see right now, all of them continued successfully. They all finished, all of them very, very quickly, 100 workflows with 100 agents facing a catastrophic failure, really. And they've just all finished in under 1 second.
So they are indestructible, effectively. It doesn't matter whether you have...
Yeah, call it indestructible if you're playing Magic the Gathering. That's a keyword from there. Immortal, you could use that. Yeah, they could. You could have your cluster literally sleeping for a year now, and once you bring that cluster back up, as long as you haven't deleted the actual database and the disk from that database, everything will just continue on running.
Yeah, so whether it's a network failure, machine failure, process blip, hardware failure, it doesn't really matter. Well, I mean, if there's a hardware failure, you still got to have a failover to it. Oh, actually, Kubernetes will handle that, yes. But as long as the Kubernetes environment is able to deploy across all these things, the things will come back and run, yes?
Yes, exactly. And to take a further look at how this works, let's zoom in a little, okay? So we've just ran 100 agents in Kubernetes with 100 workflows, and we saw how they behave in the real world with LangGraph checkpointing enabled versus how they operate with Dapr. So with LangGraph, they will get you disjointed runs. They will not automatically recover. They will fail. But with Dapr, everything continues on running, and you can rest assured that all of your workflows will actually complete whatever they're doing, which is extremely important for any system that takes itself seriously. But LangChain, actually 2 weeks ago, released something else called LangChain Deep Agents. And I just want to go over and take a look at that. Well, I have so many open VS Code here. And LangChain Deep Agents is actually using LangGraph behind the scenes, but it gives you like this agent harness that you can issue tools from. And what I'm going to do now is show you a single run of an agent that I'm running locally. And we're going to do a crash test scenario for it as well. So this is just a simple post endpoint where I'm just kicking off the agent itself. And we have a bunch of steps here. So we've got step 1, search, compare, and then confirm. This is like an event planning kind of agent. So we're creating the deep agent here. And we have the Dapr workflow deep agent runner. By the way, something I didn't show you in the last demo, but I'm actually showing this to you now. You're probably wondering, well, what do I need to do to guarantee this reliability for LangGraph outside of just running Dapr? And that's to include this single line of code in your application. That's the only thing you need to do. So in the code I've shown you earlier, you'll have a Dapr workflow lang state runner instead of a deep agent runner, because this targets deep agents. And that's literally the only thing you need to do. Well, this and this import here that you get. Once you put those two things in place, you get automatic reliability happening outside of the box. So in this case, we are, by definition, crashing the process in step 2. So this is expected. So let's run this and actually use Catalyst, which is our workflow engine platform, just to be able to visualize everything, I think, in a much nicer way than just viewing traces in Langsmith. Let me zoom in a little here, and I'm going to do Diagrid dev run. So this is just a helper method to help me issue some environment variables that are telling my Python app to connect to the Catalyst infrastructure. My code is running locally. This entire agent, Deep Agents is running locally. It's just connecting to Catalyst in the cloud. So this is going to start. And we now have it running, so we can start issuing the curl command. So I'm going to issue a prompt that says find transportation for a corporate gala. We can see that the workflow has started, and we are now executing the steps. So let's follow on here. There's multiple steps within each activity, and now we crash the process, right? This was expected. We got to tool 2. All of those steps, by the way, all of those steps, even in a single activity, all of those activities, even in a single step, are durably executed. So when the agent plans, it's being checkpointed through Dapr. When it's passing the results to the next node, it's also being checkpointed. When it's making a decision, this, again, is also being checkpointed. So any step in the plan that the LangGraph Dapr agent came with is actually being saved automatically through Dapr. Now what we're going to do is go into the Catalyst UI, which I have running here, and I'm going to go into workflows, and we can see that we have a running agent. It's not failed. Now, mind you, we crashed the process, so this is continuing to show as running. And if we go here, we have a bunch of steps, and we're going to go down until we get to execute node activity. All of those other activities that came before it contain the information about exactly what the agent did. And this is really important to be able to explain also why the agent did what he did, and not just being able to observe. So I'm not going to go into this entire metadata here right now. This is probably going to be the subject of a later webinar we're going to do in the concept of what's important when it comes to understanding what agents you're doing, so that you can stop treating them like black boxes. And today we're focusing on the actual execution. So first of all, this is a great way to see how long each step takes. So we're stuck here, and what we're going to do here is just spin this Python app back up. But what we're going to do now is actually not issue a curl command, because we don't want to start another workflow. Or actually, wait, before we're starting this, let me just remove the crash here, because now we're simulating, transient failure. Now everything should be back up and running. To see the workflow actually running to completion and starting from where it should. So actually did something unplanned. They started it twice, once with the crash still in there. So this is going to run, and what we should see is the workflow continuing where it left off, and this is exactly what we're seeing. You're not seeing tool 1, so tool 1 happened. You're not paying for that LLM call. If you're running your own model, if you're using a GPU for whatever reason, you're not going to be hogging the system and denying access to other LLM invocations. You're essentially doing only the work that you need to do. So it picked up where it left off with tool 2, going to tool 3, completing, and yes, current position has been confirmed with Premier Shuttle Company. I don't actually know if this is a true company. If it is, then they can enjoy the free advertising they're getting. So let's go back here, and we can see that the workflow now has completed, and it automatically refreshed. We can see the end output. So we have the first input, the first output here. We can expand that, and we can view all of the information. So this is the second step, found 3 transportation options, now compare. Well, this is the first step going into the second one. And this is the pre-merged cost, the best value, now call step 3 to confirm. This is the selection, so you can see exactly which step each agent took, and you're able to reason why it did what it did, and which actual tool it called.
So just a moment here. So Jeroen, just a couple of things here. First, I'd just like to get back to your, before we leave this, we should get back to your code around these things. But here, we're looking at Catalyst, which is our platform for running agentic applications. And this shows that, every particular agent that you run underneath here is backed, in this case, by a workflow. This is taking your deep agent one, showing it both as the agent view that you can see inside there, but this is the workflow that is representative to make that a deep agent reliable around the covers and the steps inside it all. And you can visualize it all. You can see the relationships, you can see the metadata, and basically you can do observe its steps around it all.
Correct. Yes. So here, for example, you have an inventory of all of your agents. The one I just ran is deep agents crash test. So you can go into here and you can see exactly which models it has access to. There's a lot you can do here, but then you can visualize all of the different workflows this agent is running, right? So a given agent or multiple instances of an agent can be running multiple workflows, and this is just a very easy way to see all of them.
Yes, and if you look into the agents tab inside here as well, it appears underneath there as an agent, yes? Yep. Running. So this, and we'll dive more into Catalyst, and you can, at the end, we'll give you a link about how you can try this all out yourself effectively with this. But going back to your code a moment, in your code, you just added sort of 3 lines in terms of here to make it reliable, yes?
Make it Dapperized and reliable, yeah.
So if you just pull that code back up at the moment, so I could take any LangGraph application, and all I would have to do is import into it the library, and then do this 1-line code here, yes?
Correct, yes. This is for deep agents. Let's see what it looks like for LangGraph, which should be here, I think, if I'm not mistaken.
So at the top there, you've pulled in that import.
Correct, and this is what you need.
And that's what you do. So it literally is 2 lines of code.
Yes, it could be a single line of code if we do something like that, yes, if you really want
to bring full reliability to this. And
that's all you need.
One of the questions that got asked, by the way, is like,
I'm going to stop sharing and then we can answer questions, yes.
Well, I mean, I just want to make sure, let's just go back to Catalyst a moment, because, if you look in that viewpoint inside here, just kind of a quick little tour around this is that, for any given, you've got your dashboard at the top there, which just shows a view of all your projects. And then you show all your workflows that are running that underneath, and you got your agent view, and then all your workflows below it all.
Yes.
And there's a few other things, interesting things you can dive inside here as well. If you look at your apps graph, I don't know if inside your apps graph you've got a view inside here. You've probably got lots of different, you've got lots of different agents running here.
Yeah. So let me explain this real quick. If you're running a multi-agent system, what you'll actually be able to see here is how they're communicating with each other. Right now, this is not a multi-agent system because each one of those agents are individually operating. But if they were calling each other, which is totally something you can do with all of those agent frameworks we mentioned earlier, you would actually see the entire application graph. And what's nice is that we will overlay metrics and tracing. So you'll see exactly who's talking to who, but then you can even isolate them and see exactly the request per second, error rates, and latency for each one of those individual agents.
Yeah, we'll dive into that. I think that's a great future topic, actually, that we can go into, just about building multi-agent applications, how you actually do coordination across them all, how you make sure that, in fact, one of the key things we've done and built into Dapr in terms of the platform is to make sure that you can use the Dapr pub sub mechanism in order to communicate between the agents, yes, and provide all that, which is another kind of whole topic in itself, multi-agent systems between them all. One question I got asked here, while you've got this up here, is like, and it gets asked, does this agent observability also allow for the evals within inside the platform, or would you still need something like LangFuse or LangSmith around all this? In other words, how do we think about other observability platforms, understanding evals, and just looking at what the agent is actually doing and the combination of how you put the two together?
Yeah, so we have a very distinct opinion on this. Let's take LangGraph, for example. They're really focusing on their added value being the agent frameworks and how they do evals. So if you're a LangGraph developer and LangChain developer, what we want to enable you to be able to do is use something like LangSmith, which is what I've shown you the LangGraph agents running on today, and use their evals because they know how to evaluate their own agents best. No one will be able to do that. Even LangFuse, which has been acquired recently and be made into a tool that's more running internally. And the reason is because it's very, I would say, presumptuous to come up with a tool that covers like evaluation across all agent frameworks. Crow AI are going to know how to evaluate their agents best. LangChain are going to know how to evaluate LangGraph agents best. And so what we're doing here is providing you with the critical gaps that these systems have that they do not provide, which is essentially security, which we'll deep dive in a later webinar, and reliability. However, there may be some systems where you could achieve your evaluation needs based on the information that we're giving you with the workflow alone, right? So this system has APIs that you can pull, and so you can have lots of signals about how your actual system behaves. You have the execution time of each one of them. If any step fails, you know exactly who fails and when. You can reason about the inputs and outputs, right? So you can basically chew that data and make decisions that allow you to evaluate your system. There's definitely lots of good things here. You might be able to get away with this. But if you have very, very complex, multi-agentic systems, then things like LangSmith and the Crow AI platform for evaluation only are going to be the best tools for doing that.
Yeah, great answer. Yeah, I mean, we do expect that to happen. I mean, even if you're using sort of Microsoft agentic framework, you still want to send some of that tracing and telemetry, say, if you're running it on Azure itself into Azure App Insights or something like that. So there's still fine to use other tracing open telemetry frameworks to send data to, yes?
Yeah, for sure.
All right, what else do we want to cover inside this demo? So hopefully what you saw from this demo then is that LangGraph by itself kind of wasn't entirely truthful about what they say about durable execution. A lot of the emphasis is, all the burden is placed upon the developer. Add 3 lines of code, and we can turn LangGraph or all those other frameworks for that matter into a durable, recoverable agents that never fail in production. And at this point, we're able to think about this in the same way. If you look across even some of the other major frameworks, if you look at the Google ADK, or if you look at Strands, or if you look at others, they have a similar sort of challenge. The major clouds, I'd say, kind of have their version of some way of putting durability very tied into their systems. But they still don't have the full recoverability of a workflow engine built behind them.
For sure.
Yes.
And there's a lot more that they're missing, and we're going to be covering that in future webinars.
So with that, let me just switch back a moment to my screen here a moment and just put my slideshow back on. And let's just dive in here. So the way we kind of frame this and the way we think about this is that there are many agentic frameworks, and how you build your applications. You're building your business agents that are achieving some sort of business task. You're choosing some framework around this all. And of course, you want to run that on some sort of infrastructure. You've got some compute, networking, storage, language models, MCP servers, a whole bunch of external systems you want to talk to. But you kind of really need this middle piece. You need an AI enterprise platform. You could call it an AI agentic platform. But that's the thing that binds the two together, that brings all the key characteristics. And the platform has really, when you start to dive into these things, it has many, many characteristics of it all. It really kind of, the way we look at it, it's divided into sort of 4 main verticals around these things. How you think about the security and governance around those agents, durability and the resiliency of those, the whole world of understanding what your agents do. I mean, we can have to be deep on agent explainability. Agents are going to be non-deterministic. You have to understand what they do. 90% of the time, they need to do what you want to do, but you need to have ways of understanding what they do, the cost, the tracing, the logging behind them all. And of course, then in multi-agent systems or communication with other systems, you need that communication interoperability. So each one of these pillars, we could spend probably many hours on talking about these things, and there's probably all sorts of subtle things that are deeper inside this. But as with any industry, and you saw this inside the Kubernetes world, if you switch back to the cloud, when cloud native computing emerged, there were a lot of people trying to stitch together a set of VMs, trying to build distributed systems, trying to use, at the time, Chef, Puppet, and all of these sort of kind of tools to kind of stitch together VMs. And then sort of Kubernetes came along and sort of solved the complexity issue of distributing and coordinating a set of processes across machines. And that sort of led into the development of microservices era around these things. We're in the same space right now, where you need to build a platform play around these things that cover these topics. And so our goal in this series is to dive into each one of these. Today, we very much touched on durable execution and bringing that to any agent framework. And we really covered this box here. There are many other things you can cover inside that area in terms of retries, failover, the whole session and memory management thing that happens inside agents. And one of my favorite areas, of course, that we are going to probably dive into lots is Security. There is so much that's needed in the world of security with agents, particularly around identity and attestation and how you do authorization, that you have to build deeply into a platform and can't be done on the surface. So our goal here really is to hear your problems, send them to us, and we will actually do we'll do webinars on the topics that you feel are most important. But we will sort of basically highlight that this platform need is really the way that the industry is going. And I think a lot of people are solving particular pieces inside this all, but there are very few places where holistic platforms are being put together. So with that, let's, by the way, if you want to try out Catalyst yourself, try out what Jeroen just demoed, go to this URL here. I'll post this in the Slack channel in a moment. And if you go here, you can try out the same demo that Jeroen just did and bring to any one of your agent frameworks, bring the Dapr workflow engine behind it all to make it resilient. If you want to follow up questions after this, just come and join us on our Diagrid Discord channel. I'll post this link inside here as well, around places that you can come there and just drop further questions, your problem space around all of this. So with that, and I've kept those links at the bottom here, I'll put them in the chat channel. Let's just trawl through some of the other questions we had inside here that came up.
Mark, I answered a bunch in chat already.
Well, why don't you talk, maybe speak about a little about them if there's some inside there.
Okay, so, well, one question was it running this on Docker desktop with Kubernetes? No, it was on GKE. Can you use this with Azure Foundry and .NET OpenAI SDK? For sure, our integration respects the OpenAI SDK, so you can bring in whatever LLM you want into Microsoft Agent Framework, and you'll get the benefits of workflow orchestration, yes. For Philip, we essentially have those integrations I've shown for LangGraph for all of those agent frameworks I mentioned, CrewAI, Strands, OpenAI agents, Pydantic. If you wanted to take an existing workflow engine, even including Dapr, and try to integrate them with a workflow, with an agent framework that we don't cover, you wouldn't be able to do that because you need extremely deep integrations with those frameworks. You need to actually extend them and reach into their bowels, so to speak. And it's very, very involved work. So if there is a framework that you want to use and we don't have it, it would be great to just open an issue and go hey, I want to see this integration. And we will prioritize that.
Yeah, I'd love to hear some of the other frameworks people are using that we didn't put on that list.
Yep.
If there are any that you are using. For example, I don't know, NVIDIA Nemo. Does anyone use that one? And we've actually been working on LangChain4j. Yes?
Perfect timing, because Philip just said some Java support would be awesome.
Oh, okay. So we got LangChain4j coming out. It's been sitting there in a PR for a while. If you are in the Java world, that seems to be one of the emerging ones, but we'd also love to hear from you, if you're in the Java world, what else you would do. I think LangChain4j was one that we certainly focused on.
It's actually coming very quickly. I'm putting the PR we have in Dapr upstream for it. So this PR enables everything you just saw with LangGraph and Python, only for LangChain and Java.
Okay. If anyone would like to post in the window here, in the chat window, what topic you would like us to dive into next in our next webinar, which we're going to do from a month time. We're going to do this every month. So probably about the 20th of May, we'll do another one of these again. If we can do more frequently if you think that there are so many topics. But we were going to dive into security probably next, and looking particularly at security of MCP servers. There's been a lot of discussion recently about MCP as a protocol. I think there's a whole topic itself around how you secure MCP servers, and particularly what I think is one of the critical things that we've encountered is that a lot of organizations are looking at their internal APIs. They're wanting to think about how they bring agentic applications to talk to them. They're layering MCP on top of them all. But the first thing that's running into is the SecOps team is going whoa, stop. You're not touching any of these things with those agents unless we have a clear security model about which agents can access which MCP service. So one topic to throw out there. Love to hear anything else that people would be interested in hearing. post something inside of the chat window, and we'll touch on some of those.
And also feel free to join the Discord and talk to us there. It's also
yes, I've posted Discord there. We have a kind of a general channel if you want to go to that and just post questions. If you want to reach out to myself and Yaron directly, you feel free to do that. We have our emails here at the top here, mark@diagrid.io and Yaron at diagrid.io. Drop us some emails on those. Discord's probably the better place though, just because then we can have more of an open discussion. It's easier to cover those things.
I see there's a few more questions in the Q&A, by the way.
Okay, dive in.
Yeah, so one question from Mustafa is, will this reliability, durability also work for agent-to-agent communication? Yes, 100%. If you're looking at agents as tools, right, where LangGraph uses a tool to call another agent, and that tool fails, then yes, that call to the external agent will also be replayed when it failed. So you're covered with pretty much any agent framework that has this. Dapr agent specifically, which is the agent framework we have under the Dapr project, has this implemented very transparently. But yes, you will get this if you use any of our integrations with the existing frameworks today.
Yeah. If you are, one of the things we didn't really touch on very much, maybe it's a future episode. We've done a few of these things if you ever go into the Dapr community, but we built an agent framework ourselves into Dapr, which by default became as durable. In fact, it's durable by default. So that if you are thinking about, oh, I'm picking an agent framework of choice, it's a Python implementation, try that one out. But the point is we really don't care. You can bring any agent framework you like. You can invent one tomorrow for all we care. Bring it. Thing is, we can make that durable and reliable with Catalyst, our platform. And that's basically what we do inside here. Going back to the resiliency and the security aspect we talked about earlier, the platform that we've built here at Diagrid is Catalyst. And Catalyst provides probably everything you could see inside this diagram, inside this image inside here, in terms of all the capabilities across security and governance and reliability and durability. I think one of the things, as I say, we'll get into is security next. We'll do that next episode. Okay, well, I think we're getting close to time.
Yeah.
But I always like it to see if there are any other questions in time. If not, what else? Any last closing thoughts on this, Yaron?
No, I think we covered a lot. It'll certainly be interesting to see how security and governance find their way into workflows, right? Because if you're thinking about agent identity, everything is a workflow. An agent is going to talk to another agent from within workflows. So how do you propagate identity so to not leave the verification or authentication authorization steps for the agent to do outside of the workflow? And how do you tie all those in together? And this is, I think, really where we're going in the industry. We're moving from workflow orchestration to agentic orchestration, where the workflow is the main piece, but it involves just so much more, like observing different steps and being able to do chain of custody preservation for them, and being able to audit each and every step and deciding, or be able to verify that the actual entity that created that step is the one that should have. And doing authorization, authentication, all from within the same really simple workflow model.
Yeah, in fact, let's do that next time. In fact, let's dive into that, because I think our claim is this. And I think we're very confident in our claim. I don't think that there can be any agentic system that you can ever reliably take to production that isn't backed by a workflow engine underneath it all. I don't think it's actually, I think unless it's backed by a workflow engine, I think it's non-viable.
Yeah.
And not only non-viable from just that reliability side, but from what you just alluded to, when an agent calls another agent and that in turn follows another agent, that call chain itself and the attestation across it has to be maintained. And you're going to get into these scenarios. We already are at these scenarios where you're going to have to trust these agents with an identity. It's like a human having a passport. They have to have passports. And you're going to have to also trust that another agent did something correctly beforehand. So did that agent do that transaction beforehand before I allow you to do the inventory around these things? I mean, and so you're going to have this attestation chain across here from agent to agent. It's easy when you have simple agents and single agents and chat agents, but the authentication, authorization, chain of attestation is going to be the thing that's critical if you're ever going to trust these agents to do more than take on the same work as humans. That's why this security and governance is the biggest box really inside here. Around.
Okay.
Excellent. All right. Well, let's close this out. I had a fun time. Loved your demos.
Me too. Thank you so much, everyone.
I've seen your demos so many times, but I still get a massive thrill out of them.
I do too, as someone who's run them 100 times. Also, Mark, I think we maxed out our Langsmith bill. So.
All right. Well, thank you for joining us today. We'll post this webinar afterwards. We'll post the slides to go along with the webinar. And please join us on Diagrid Catalyst
Discord.
Discord. And see you next month. Thank you.
Next month. Bye-bye.
Bye-bye.